Hello and welcome to this video in my Networking Basics series. I'm Wolfgang Tremmel and I run the DKIX Academy. This whole series is about introduction to networking topics, and if you want to see more of this series, Networking Basics, or other content from the DKIX Academy, just head over to our website and have a look. There's a lot of stuff there. There are videos, there are white papers, and also other content interesting to see or to download. Okay, let's get started with the presentation. This is part 3A, where I talk about IP addresses. In part 3, I introduced the IP protocol, IPv4 and IPv6, and I showed how headers look like. So this time I'm talking more about addresses, what are prefixes, and what is routing. Let's get started with a short recap of the IP protocol. We introduced the internet layers, the internet model of how the network layers work together. With the IP protocol, we are on layer 3. The data units here are called packets. And the purpose of layer 3 is, of course, to provide source to destination, so end-to-end transport. And of course, for this, we need addresses. Addresses for your computer, your smartphone, your watch, whatever participates in the internet needs to have an IP address. And as currently there are IPv4 and IPv6 protocols both running in parallel on the internet, we have IPv4 and IPv6 addresses. IPv4 addresses you might have seen before. They are 32 bits in length. There is 4 billion possible addresses. Usable of these 4 billion are about 3 billion. And they are written as 4 decimal numbers and separated by dots. Some of these addresses are reserved and not usable. And keep in mind, all usable IPv4 addresses have been assigned to internet service providers or end users. So there are no more IPv4 addresses left. The only way you can get these addresses are if you purchase them on the free market for an unnecessary lot of money. But there's a solution, of course. Just do IP version 6. IPv6 isn't new. The development started in 1994 and it was first published in 1995. IPv6 addresses are 128-bit long, so that gives you a really huge number of usable addresses. So a lot of them are available. And the writing is a little bit different than IPv4. They are written as hexadecimal numbers separated by colons. So hexadecimal numbers are numbers 0 to 9 and also letters A to F. And the addresses are, of course, a lot longer, which makes them quite hard to read out in a presentation. And but there is a way to shorten these addresses if there are a lot of consecutive zeros. So the double colon here means fill up with zeros. So all these 3 addresses you see here are actually the same address, just with the shorter writing of the double colon. Also in IPv6, not all addresses are usable. Some are reserved, but still it's a lot more addresses than IPv4. Yes, let's go back to the internet model. And the purpose, like I said, of layer 3 is to provide end-to-end transport. So from here to Australia or wherever in the world you want to send data. So Let's have a simplified view. This is, of course, not how the internet looks like. There is no direct circuit to Australia. End-to-end doesn't mean that each and every destination has one dedicated circuit to reach it. It's a lot more complicated. There are so-called routers. Routers are operated by internet service providers, carriers, and they are interconnected between each other. They are connected with circuits, with fiber circuits, with undersea cables, whatever is available. And these routers forward your data. They send your data hop to hop from one to the next one. So to send data from Europe to Australia, it goes along a lot of these routers until it reaches its destination. So this is the path it took. And of course, the question is, how does it find its way? And this is also where, again, IP addresses come into play. So we know the destination IP address where we want to send data. So each router on the way has to know where to forward a data packet. It has several network connections, several leased lines connected to it, and it needs exactly to know which one to send your packet through to the next hop. So here in this case, we have the destination address. The selection which way to use is always made on the destination IP address. And it knows where to go and it sends it out. And this is what we called routing. Short intermission here. About language. I'm not a native English speaker. I'm German. So when I learned at school to pronounce this word, it was said routing. And this is a proper pronouncement. But why do I say routing? This is how I speak in my presentations. Routing is a method of finding paths from origins to destination in a network, such as the internet, along with information can be passed. That's the Wikipedia Wiktionary entry. There is also a word named routing, written with double O, and that means a hole formed by a pig when it roots in the ground. So to distinguish between the word routing with double O and routing with OU, I pronounce it routing. So let's talk about routing. And let's talk about routers, because that's are the devices who do the routing. All IP packets, like I mentioned in the last presentation, they have a destination IP address. And this is all the same for IP version 4 and IP version 6. And depending on that destination IP address, a router chooses a next hop. So the interface through which the packet is sent out. For this, the router has a large table, a lookup table, to check where to send which packet. This is called, of course, the routing table. Does it contain a lot of single IP addresses? No, it would be way too large. There are so many IP addresses, so we have to group them somehow. We are grouping this table by so-called prefixes. So you already know what an IP address is, but what is now an IP prefix? Let's start with IP version 6 addresses. This is the notation I introduced. This is how it's written. It's 128 bits long. Each of these addresses, they have a so-called network part and they have a host part. And the prefix length, the prefix just notes the network part. And in this case, the network part is 64 bits long. For the whole address, of course, it contains with a network and the host part. But what we call a prefix is just the network part, and the host part is all zeros. So we have a network part of 64 bits long. We write it with a /64, and also that means if we put it into a table, if we write it down, the host part is all 0. And the same is true for IPv4. In IPv4, just 32 bits long, there is also always a network part and a host part, and the border between network part and host part can be anywhere. I didn't mention that, but the same is true, of course, for IPv6. The border between network part and host part can be anywhere. We write it with a slash and with the length of the prefix, so the length of the network part. And also in IPv4, if we write down a prefix, the host part is zeros. And it doesn't mean decimal zeros, it means if we write it down, the single bits, all the bits in the host part are 0. So let's make a short comparison between IPv4 and IPv6. You've seen it, the writing, it's just IPv6 is just longer and with hexadecimal instead of decimal. But for prefixes, the same is true. It's written with a slash and with the prefix length, and the host part is 0. So now that we know what prefixes are, let's talk about routing. In routing, a device, a router, must make a decision. It receives an IP packet, and it must make a decision where to send it out. For this, like I said, it has a routing table containing prefixes. So we have here an example of a small routing table containing two prefixes, a /16 and a /24, and it must make a decision where to send out this IP packet. And if you have a look at the packet, you might say, oh, both entries match. Yes, that's true. But one of them, the lower one, is a smaller prefix. Sorry, it's larger in case that the prefix has more bits in it. So we say it's a smaller prefix. And this is what we call a more specific prefix. The /24 is more specific than a /16. And so it sends out the packet this way. And the routing table, of course, doesn't just contain two entries, it contains a lot of entries. And how does it work in practice? Well, simple. We just sort the routing table by prefix size. Let's just do that. And then we try to match the destination address of our IP packet to the routing table. We check that entry by entry. We take the IP address, we apply the net mask, in this case of /24, in the routing table. We make a logical AND with the network part. So we mask out the host part, and then we check if it matches. And in this case, well, you see, it doesn't match. Then we use the next entry. And we do the same calculation. We take the entry, just the prefix, we do our calculation, we apply the mask, and then we check if both are the same. And in this case, they match. And now the IP packet, the router knows where to send out this IP packet. Well, You now know how routing works. Of course, in practice, this has to go incredibly fast. So there is not just a comparison, there are caches and there are algorithm involved to make this really, really fast at line speed. But in principle, it works this way. The router goes through its routing table and finds the best matching entry for each destination address. And this tells the router where the next hop is. It doesn't tell him where the destination is, just the next hop, but that's enough. And then it sends it on to the next router and the same game begins again. But how to build this routing table? How does the information get into there? Well, the simplest solution is somebody types it in. And this is what we call static routing. And it often happens in small networks. It's simple, it's often used, but it of course doesn't scale. If you want to have the whole world, the whole internet in your router, you cannot type it in. And for that, routers kind of talk to each other. And that's what we call dynamic routing. And for that, we need a protocol. You know that if two systems want to communicate, they need to have a common protocol. And these protocols are called routing protocols. Example for routing protocols are BGP, that's Border Gateway Protocol, that's used in large-scale international routing. OSPF, that's Open Shortest Path First, that's for local networks. ISIS stands for Intermediate System. Same also for inner provider routing. RIP and EIGRP are also protocols no longer that often used. So, conclusion. This time we introduced a lot of new terms. We talked about routing and have a look at the formal definition and also have a look at Wikipedia. We talked about a router, which is simply a device which routes. And we had the term of the IP prefix, which is the network part of an IP address. And it's written with an address and with a prefix length. Also, I introduced the routing table, a lookup table in each and every router, which tells the router where to send packets. Okay, and that's it for today. Thanks for listening, and have a look and download the presentation. It contains a lot of additional links of stuff which you can read for further information. Also have a look at all the other videos of the DKIX Academy, and I see you next time in the next video. Thank you, bye bye. I'm Wolfgang Tremmel from the DKIX Academy.